I know this building.
Ah, okay.
It is us.
I was thinking,
It is us.
wow, that's enthusiasm at this time of the day, at the very last session. I really appreciated the enthusiasm. So, as we are a little late in the schedule, let's start immediately. So, first of all, thank you all for being here. One of the very last sessions, so I really appreciate you still here with us. So it will be a short presentation and to stick to the time we have. My name is Debora Testi. I'm from the CINECA Supercomputing Centre in Italy. I'm here with some of my colleagues, and I will give a short presentation on how we support a research project in the domain, life science domain on the cloud. So, just a few words on who we are. So CINECA is a consortium of university research centers in Italy. It's a non-for-profit. We were funded in 1969, and since then the Italian Ministry of University and Research has delegated us for the development and management of the high-performance computing facilities in Italy. For this reason, CINECA is the most important supercomputer center in Italy. As part of this, we serve numerous community, researchers and research centers in Italy and in Europe in very different domains. I mean, whatever you can think of, environmental, astronomy, chemistry, etc. But what we were asked by many users in health and life science was to help them with in some issues. The first one is the most obvious one, so to provide them with the computational capacity they do not have in-house. Support them in the optimization and execution of models, machine learning models, sorry. And also support the development of data management workflow involving sensitive data. All of this, as you might expect, as we are talking about life science, biomedicine, as I said, bioinformatics, we are dealing in most of the cases with sensitive data, which means either genomics, omics in general, clinical information about the patient, and so on. And for this we have very strict regulation like GDPR. So this regulation, of course, poses some challenges in terms of security and privacy of the data that have to be addressed. There are different strategies you can use from the technical point of view. Of course, encryption is the most obvious one, access control, and many others. But which was the challenge we faced? So, high-performance computing clusters are not designed for their nature for this kind of isolation of the data, isolation of the workloads, because they are meant to be a shared pool of resources that everyone can use whenever they need. So we needed to move towards cluster research environments, and it is there where cloud infrastructure came into the picture. So this is the story of cloud infrastructure we deployed at CINECA. We started 10 years ago exactly, and then we had number of machines. Now the cloud, HPC Cloud cluster, which is in production, is added. We have 2 other systems that are being deployed as we speak, and we have over time increased the capacity of the system. So the idea why I call it HPC Cloud and not just cloud, because the systems are meant to combine the high-performance computing typical of HPC with the flexibility of cloud. So they have, from the architecture and hardware point of view, the characteristic of HPC system, but is cloud-based. All our systems have been always based on OpenStack. So with these systems, we of course serve a number of use cases, not just what we were mentioning at the beginning. I will not go through all of them. This is just to show that, of course, it's a general purpose infrastructure that is used by many different communities in different domains. What we are focusing here today, in this talk is, as we said before, the hosting of workflows that are processing sensitive and controlled access data. How we achieve that? We achieve this from two different angles. One is, as we said, the technical one and the security measures that have been put in place, and one is more on the organizational and administrative process on how you manage this, the provisioning of the resources to the users. So let's first look at these organizational procedures. So we have two sides of this. One is your relationship with the researchers and the end user of the system. Due to the specificity of the data, we put in place more, let's say, formal agreements with the researchers that we normally have in other domains. This involves, for example, the formal appointment of CINECA as data processors by the data controller, according to GDPR, and also we normally outline an agreement or a contract depending on who the researcher research group is, which clearly states which are the security measures that have been implemented and used by the specific use case, and even important, as well as important, the role and responsibility of everyone. So who is responsible for what, who is doing the backups, who is managing the creation of the account, and so on. Internally, we also work a lot on setting up a serious, quite many I have to say, procedure, policies, and operational guidelines to manage different aspects of the provisioning of the resources and the projects. These are just, I would say, the most important. There might be other, but just to highlight some of them. So first of all, the creation of the accounts, how you manage them, the review of the accounts, and also, of course, the privileges that are associated to the different accounts that are created. How you collect, maintain, and who can access the logs of the system, so to understand who has done what and when. Procedures for backup or disaster recovery if needed. Not everyone needs this, but in case needed, we have procedure to find this. And MBI of the management of the infrastructure and operation. With this, I mean how you apply changes to the infrastructure, change management, how you deal with incidents if there are incidents, how you give support, and so on. On the technical choices, so at the level of the infrastructure, I list here the three that I think are the most important one. One is access control, so only authorized users have to, of course, have access to the data. We set up two-factor authentication whenever it's possible. Of course, not all the time is possible, but whenever it is, we use it. In the OpenStack implementation that we have included the Barbican Key Manager service, which allows to create encrypted volumes for the data, and we have a secure connection. In some of the cases, we also work with the communities in the development of the software or the application that tend to be used by the user and to process the data. And in this case, we use a completely privacy by design approach. So, of course, there is identification of risk for data breach or data loss from the very beginning and monitoring of the risk along the time of the project. We perform data protection impact assessment, and not only we perform the assessment, but we share the results with the user at the time of the signing of the agreement. Before going to production, we perform vulnerability, sorry, I would never be able to say that, vulnerability assessments and penetration testing. And we do this before going to production, and then at any major update, let's say release of the application, but at least once a year, even if nothing has been changed in the application. And then, of course, if there are issues, we address the issues. I will now just share a couple of more practical examples where we can see this put in place. This is one example from the network of Italian genome. Their aim is to create a central repository of human genomic variants that are collected in different sites in Italy. So, as you see, human genomes, so very sensitive. I will just, instead of reading on the picture, I will just describe the picture here. So basically, the overall workload is designed around 3 virtual machines. Only one virtual machine can be assessed by the researchers. This is the front end of the system. Then this share with other 2 virtual machines an encrypted file system. And the second virtual machine will do the computation of the data, then save the output, which will be aggregated by the third virtual machine, and the results, which is aggregated data, which are also anonymized and with no personal information, are then shared back to the front end. So the user that is accessing the system will upload the data, which he has control of because it is their own data, and as, let's say, post-processed data, they will just get aggregated and anonymized. So, and the second and third virtual machine are not reachable from, say, the internet, the public network. They can just be reached from the internal network of CINECA from specific IP addresses. So there is no risk that, reduced risk that someone can break in and get through. The other example is quite similar, but with some differences. So this is for the orchestra project, where they collect cohorts of data for the assessing the prevention and treatment of infection from COVID. So that started during the COVID pandemic, but it's still up and running and still used. The approach is pretty similar, so there is, again, a data portal where the user can access. In this case, there is the specificity that the user, in order to perform analysis, will get a specific token to process a specific set of data. So it's very, very controlled. Also, in this case, we have 2, let's say, backhand virtual machine with the tools that are used to make the analysis and the aggregation of the data. Again, connected to an encrypted volume from connected to the machine. Yeah, last slide. So all these elements that you have seen have been put in place, and since 2022, CINECA is certified ISO 27001. Specifically for life science project on HPC Cloud. Now, next week we have the in next 2 weeks we have the verification and audit for the extension of the certification to all, hopefully, to all projects under infrastructure as a service model on HPC Cloud. So it will be for all domains and not for just for life science. This is quite a lot of work, most of all from the, I would say, from the organizational and administrative part. But we see there are a number of benefits. Of course, there is a benefit in your relationship with the user that has these specific needs, because it increases trust and credibility. It also gives a bit of a competitive advantage, because there are certain cohorts or certain groups that would work only with centers that have the certification, so of course it gives a competitive advantage. But it also gives some benefits internally, because it increases in the staff and the team members the awareness on the risk associated with the managing of this kind of data, and formalize some of the processes that are important for incident response and continuous improvement of the system. That's that. Thank you very much. We are a bit late, but if there is Yeah, please.
Did you have a policy for user removal?
User removal, yeah.
Because I'm curious.
Okay. So user removal is more part of the say. It's not specific to cloud. Is for all the users that we have because we try to standardize whenever possible across all the system. And there is a process. Let's say after a certain time that the user does not have active projects on the systems, it is sort of disabled. And then after another period of time, I do not remember if it is 1 weekend or whatever, after a period of time that the user does not have any active project on the system, then the account is closed.
Okay, and also the data. The data.
Okay, the data is different, meaning that the data are associated not to the user but to the project, that where the user is maybe the main reference person. So for the cloud, there is for both HPC and cloud, there is, let's say, what we call grace period, so a little bit of period of time where the data are still available to the user in order to maybe retrieve something they forgot to save before the closure of the project, and then everything is removed. Yeah, please.
Thank you for the talk. How many applications are you supporting? You have lots of effort for securing software and all this tech. How large is the number of applications you can provide with this high?
Okay, so how many? So
does it scale?
Yeah, so at present it scales. Of course, the paperwork is maybe the most slow process, I would say. But yeah, so far it scales. I think, so I don't know how many life science projects we have now running. I'd say on the order of 10, let's say. Not a huge amount with but so far it scales. So we hope to have, now we are going to a bigger machine, so we hope to get more users and more of this kind of projects. So yeah, let's see. We think so. Yeah, just one then.
Encryption, is it ensured at rest, not while the applications are running?
Yeah, and the encryption is, first of all, is of the volume, not of the data, so is volume encryption and is at rest. Then there is secure communication across the different parts of the system, but it is at rest.
Okay, so you have to trust the administrator.
Yeah, yeah, of course. So if you're okay, I will close here and leave the floor probably for the next speaker. Thank you very much.